Okay, so this is session 3, group 2. So, as you probably saw from the video, one of the things I forgot to bring up was the use of sub-VIs. In C they're called, subroutines or something? Basically programs that you nest within other programs that have particular functions. We use them all over the place in all the previous examples. Let me just open up, yeah, this one. All of these things are essentially, their own self-contained ones. Some of the higher function ones can be easily checked and kind of edited, saved as different names. But this one, for example, if you double-click on it, you can go in and see, what makes up this kind of sub-VI. Really, really, really bloated. For what it does, it actually it does a little bit too much. It does more than what is exactly necessary, and a lot of it is for checks and balances and things to just about account for every possible thing that you might have in a folder that you're trying to read. But because we don't need to be anywhere near kind of that thorough, we can write more simplified versions. So what we're going to do today is look at a replacement for this recurse file list, or kind of tell me all the files that are in this folder sub-VI. We're going to make our own version of it. And the reason being, like I was kind of showing in the video, is lower level code, Windows included. Windows now is much better at it, but when Windows orders a file list, it starts from left to right with its numbering scheme. So easiest to, I don't know if I saved it. Easiest to demonstrate it is if you have a string of 1, 2, 3, 4, 5. It will put them in that order. But as soon as you have like 10, 12, 13, most things will actually start putting these after number 1. So they'll insert all of these guys over here because it goes from the first index first. And most people actually have seen this a lot, especially if you've used computers for more than the last 4 or 5 years, because it always used to be true. If you ordered your file structure by file name, you'd always get this weird insertion, and it's because it lists left to right. And Labview's VIs do exactly the same thing. So all of our previous examples have a bug in them, and this is the bug, that they're reading a file list which is numbered wrong. So we can't, I noticed it and it's bad, but we have a solution for it, and it's essentially to, rather than using this little VI thing here which lists the folders and orders them, but it orders them this way, where it indexes from left to right, we essentially write our own little sub-VI that, explaining what it does exactly, it filters and then sorts the order, and then tells you kind of what this list is. So going from left to right, you choose your file location. This then strips the path off that file location. We then have this kind of list everything that's in the folder sub-VI, but we're applying a pattern to that to choose exactly what we want to filter. And for this example that I was using a particular data set that was using confocal data. So we were just pulling out one of the fluorescence channels. So this will only list files that finish like ch00.jpg. Once we got that kind of filter on there, the difficult part was to trying to come up with my own way to list and order these things, because, well, for me it didn't, you had to kind of think in a different way. That you take a number and you have to think of a way of putting all of these numbers in an order, and it isn't entirely obvious exactly how you do that. The way that I came up with seems to work, so it's one way of doing it. What it does is it takes this list And we can treat this, because we know that Labview essentially will order this list wrong, we can treat it essentially as a random arrangement of files. It puts them in an array, but we're using this for loop to index this array. So then it picks the first one in this random arrangement of files. It essentially creates the file name for where this file was. It then does two things. One, it turns this file name into a string. So we take the whole file name and we make it into a string. You could do it with just the last section of the file name. I did it with the whole one just to make this last section easier. But it takes this whole file name, turns it to a string, and then tells me how long that string is. So it tells me how many digits this text string is. It then creates a cluster. So rather than having just a list of file names, for each file name, it now has a secondary attribute of how long that file name is, and then puts it together as a cluster. And the important thing is that we put this file name length as the first item in the cluster, because it will order them just like with the numbering scheme. It starts at the first index. So if we put something at the start of the cluster, it will order based on the first item in the cluster first, and then it will do the second item in the cluster. So we have this cluster. We then apply a standard, order order this list. So what it does is it takes this list of file names, including the file name lengths, from this random list. It then sorts it based on the file name length first. So if you have a file name length of 10 characters, or I shouldn't say 10, a file name length of 1, then that goes first. If you have a file name length of 2, but then you have everything from 10 to 99, then it will order them first into the category of this is now got 2 file name. This file name length is 2 first. So then you have all of the file name lengths that are ordered with 2, that have 2, and then it orders within that list. So in a sense, we're adding an attribute so that we can choose our own ordering scheme. And then because we've added this extra attribute of file name length that we have no use for, we then strip that back off each and every file name, and then we rebuild this file list. So just quickly, we list what's in there, we add an extra attribute to that file name for each file name. We then sort the list based on file name length before we sort it by actual file name. We then strip off the unused file name length and rebuild the list of files, and they will be all in order. And I'm bringing this up as an example is that this is a very, very common thing that you have to do. You have to run things that are in folders, and quite often there are more than 10, 100, or 1,000 files, so you need to make sure they're in the right order. So this is a type of sub-VI that you would use quite a lot. Okay, and just to explain what we've got over here, to actually recognize the sub-VI on your block diagram, you have you have just general icons. They each have their own. They have their own attributes too. We use this as an example. We have some picture, and we have a certain wire set, and each wire has a different name that we wire in. So we have to make our little icon-y thing. We have to make our kind of wiring scheme as well for inputs and outputs. So we're going to start with something simple first, and then we'll kind of go on to this, which is more complex. So we'll explain how to build a sub-VI first. We'll use a sub-VI, and then we'll go on to building a complex sub-VI that can be dropped. So this sub-VI can be dropped straight into the other programs that we made as a replacement for that other option. And then you should also notice that the data doesn't look anywhere near as noisy as it did before, because we're not constantly going back to an earlier value. I don't know if you noticed, but it was very noisy because it was pulling in early values later on in the order. So it was kind of dropping down to really low values quite a lot. But if you actually do it now with this data, with this program, you'll notice that it's much smoother because it's in the right order. Okay, so first of all, let's make a new VI. and we'll make a very simple sub VI first. Okay, so the one we're going to do is going to use really simple input outputs. So we're going to do some things to a couple of numbers. So if we right click on the front panel and then just put a numeric control down there. Standard numeric control. Just stick it on your page somewhere. Okay, and we'll just call this input 1. Okay. If you, on the little icon in the top right on the front panel, if you right click up there and then go to show connector, you should then have something that looks like this. So this is the default connector for all VIs. You can change how these connectors are laid out, but for the most part it's just personal preference. So if you right click on it and then go to patterns, this kind of shows you how you can wire them up. Really the only reason to go to anything else is if you have more inputs than the default allows. There are times where you actually need, something more complex to I mean, I've never used this one, but I think I've used this one before. But there are times where you need to have many inputs and outputs, so then you might need something more complex than the default. But the default for us is fine. So
what's wrong with all these options from at terminal and onwards don't actually come up there again?
Which ones?
At terminal and everything below is gray for me, so I cannot select anything.
I don't know why that would be the case.
Okay, I don't know, maybe I just
You first need to switch to another show connector.
Show connector, yeah, sorry.
Okay, there it was.
Yeah.
Oh, there they are. Oh, thank you.
Okay. But this one is fine, so we'll just wire this guy up. So the way that you actually wire up the connectors are, you have your little spool of wire, which you should automatically have highlighted because we're on the connector. First of all, you just click on a box that you want to use. So generally the first one goes in the top left. And then you just click on the control or the indicator that you want to connect it to. So we click that one. And then it should change to the color, which represents the data type. So this is orange because over here it's a double point precision number. Okay? Okay?
Mm-hmm.
Okay, and we just want to, do a couple of, do a very simple thing. So we need a couple of text inputs. So if you right click, so hold down control, sorry, not right click. So if you hold down control and then click and drag to make another one. It's just a quicker way of doing it. There you go. Okay, and then we want to do some operation to this. So we're just going to do a very simple, so right click, go to numeric, and we're going to add them together, and then we're going to square them. Okay. Again, we need to see what's coming out of here. So if you right click over the dot on the square, you just go to create indicator so we can see what the result is. And we can change that name to something like sum and square. And because we've got that fancy button, we'll click on clean up our diagram. And then we might as well put things in the right place. Just to make it easier to look at. Okay. So we should have two inputs. We're summing them together, we're squaring them, and then we get an output. Okay, now we need to wire up the input 2 and the sum and square to our little connector. So kind of just pick another point on your connector and connect it to the input 2. And then pick something on the output side, click it to the sum and square. So the input side and output side are conventions, but they by no means have to be stuck to. It's just convention, things go from left to right, but you can wire it up the other way around if you want to. There's no downside to doing that. Okay, so we now have something that happens. We have an input, an output, and you know. Okay. Okay. So now we just want to give it an icon that we can look at. So if you right click on this thing up here, and then go to edit icon, not show icon, sorry. You should bring up this box. And you can, just give it something so it looks different to the kind of default symbol so you can easily distinguish it on your diagram. So the one that for this example, the easiest way to do it is go to mathematics, and then grab the plus symbol and stick it there. And go to the text symbol and we just put a big 2 right here. You just have to select the whole thing and delete it first. And just cut out that zero. That one. Yeah. Just draw a box and cut out that. So I'd leave the black line. It's kind of easier to see it if you've got a black line there. It's not, you can use the default, but when you have more than 1 or 2 sub-VIs in your program, you'll want to start putting pictures on them because it gets really hard to distinguish one VI from the next if they all look identical. Okay. And then once you've done that, just go to File. Excuse me. Go to File. Save or Save As, doesn't matter. And then put it somewhere that you can find it. I'm just going to throw it in the desktop. We'll call this sum and square. Then once you've done that, just close down the sub VI so that it goes away completely, and then get a totally new blank VI. Just close it, get rid of it. I can close that too, I won't need that. Okay. Yep, we good? Almost. You good? Okay. So once we've got a totally new blank one, now we want to call our brand new sub VI. So right click on the block diagram and go to select VI, and then you have to find that one you just made. So for me it was that one. Okay, and now just like anything else, it has its own diagram and stuff. Yeah, that's why I was saying that if you leave the box, it's easier to. And if you hover over it, you see you've got 3 connectors. And in fact, if you go to Windows, help and show context help, if it's anywhere near your page, it should give you a quick description. Okay, I've got input 1, input 2, and then sum and square. So immediately we can tag a description so you can describe exactly what it is. For something like this, we don't need to. But we can see quickly what our inputs and outputs are. So we just want to use this and make sure everything's running fine. So, and also because we defined what types of input these ones are and types of output, we can use just create on here. We don't have to make them on the front panel. It knows what values it needs. So if you right click and go to create control, then create control, and then create indicator. They should all be named exactly the same as what you named in the sub VI, and they should all be the same type as what you set them as in the sub VI.
How do you place the previous one again?
How do you do what? Sorry.
How do you place?
Put this one?
Yeah.
So you got to right click.
Okay.
You got to select VI.
Okay, there you go.
And then find the one that you want, and then you should be able to just drop it on the screen. Okay, and then once we've got this kind of very simple thing, just so that it's a little bit more interesting than running once, because right now it will read this input, read this input, add them together, square them, and they give you the output. And then the program will stop. We want to do it in real time because, running once seems a little bit boring. So if you right click, so what we want to do essentially is wait for a feedback from the user before it stops doing what it's doing. So we want to put it inside a while loop because that's the one that waits for feedback. So if you go to strictures and while loop, draw it over the whole thing. So everything's in a while loop. Then we want to put a big stop button on there. So, make a stop button. And just wire it in. So we'll do this a little bit better. Okay. We also don't need this VI faster than we're able to respond, so we should put a little time delay in there. So if you right click on your block diagram, go to timing, go to wait, and then we put a little, 30 millisecond wait every loop, because we don't need to run faster than real time. It's not necessary. You should have something that looks a little bit kind of like that.
Can't find these inputs anymore. I have no folder.
Which ones?
The input 1, input 2, and create and work.
Already are.
Yeah, that one already have. There's a weird sign.
You can just create
Control probably.
control for okay. This when you right click on the when you move.
So when we when you write the sub VI in this manner where we have a defined type of input output, it automatically renames everything to be the same as what's underneath. If you like went to the front panel and made inputs and then wired them up, you then have to rename them to be the same as what. You don't have to. It's just an ease of use. It actually carries the name with it if you tell it to make it from the sub VI. But anyway, you should have this, and then you should be able to just run it. I mean, probably best off. Actually, I don't know. I wonder if 0 is going to give me an error. No, it doesn't. And then because it's running, we can just, right now it's just adding the numbers together and squaring them. Nothing unexpected. But pick some numbers that you know to make sure it works. Unless you know that you don't have any errors, and then once you finish, you hit stop, and then it closes, it stops the VI. We're all good. Okay, did it work? Good. Okay. So, we made a little sub VI and done some things to it. What quite often happens is that you might need to make modifications kind of on the fly, and if you have lots and lots of sub VIs, generally it's easier to open them up straight away. So you can actually just double click on any sub VI and it opens it up so that you can edit it. So if you got a show block diagram, we can see, this is what our sub VI is. Now we can edit this, to our heart's content, and then it'll automatically maintain everything on the front page. You can even add more inputs, and then you'll get, extra nodes showing up on this one too. So yeah, you can just about do anything that you want to. Just showing you that sometimes it's necessary to change the components within a sub VI, and you can. Okay, so any questions on how we create sub VIs? The only real difference between a VI and a sub VI is how you wrap it. They run on their own independently. They don't have to run on their own independently. You can choose ones where the inputs are not there. So for example, if I was we can use a vision example. If I was making a sub VI which did used, opened a file and put it into a memory buffer, without having something wired into this image, it will not think this is a fully finished sub VI. And what we have to put in there is essentially a pointer for a buffer. So we have to put an IMAC location in there. Most standard conventional vision people will say always just right click and create control. Okay, so create a control to an image location, so that what we can do is wire it up. What you shouldn't do is actually create the IMAC in the sub VI, because there's always a chance that you have two names that are identical and then you get competition. So if I created something there called temp image 1, if I use temp image 1 in a sub VI and temp image 1 in the main VI, it would have issues. But if I do this and then essentially wire it in, so that's here. So essentially I can take my if this was a sub VI and I had my connector here, what I should do is wire this image into here, so that this sub VI won't run unless there is a pointer to a section of the memory right there. But on its own, it will not run this VI. So not all sub VIs can be run on their own. Most of them can, but it's not a necessity. Okay. Okay. So I think we've got just about enough time to build this this new type of file sorting VI. So, any questions on how we make sub VIs or why they're used? We all good?
How can you make these different inputs? Compulsory and non-compulsory?
That's a good question. I have no idea. Generally, all the ones that I do is all the outputs are non-compulsory. All inputs are compulsory. So that's the default. So the default is all inputs have to be wired, all outputs don't. Bear in mind that it always references the program. So if the backend doesn't require an input from one of the things, then when it's used in a parent program, it won't require it either. But I've never written a sub-VI which has a non-dependent input. They all...
These arrow inputs are probably...
Yeah,
needed.
those aren't needed. I mean, you can add them or remove them. There's not. Yeah, so I mean, technically, those ones I've done. I don't know how it distinguishes it. To be honest, I've never really thought about it. I'm sure there's some explanation about it somewhere. I don't know. But as a general rule, there are no dependencies on output. The program will work fine as long as it's got input. Okay, so so this time we're gonna do this sub-VI. On its own, if you run it, you'll just get a list out, and the list will just be within the program in an array. It doesn't write it anywhere. It just makes a list, and it kind of is a very common sub-VI kind of structure where it can be run on its own. You just don't get any output. It just writes a list internally. And it also is, I tried to keep it a little bit common by running this error thread through there, because it is a common thing to run the errors through, and I do it a lot too. So, but if you actually look at your block diagram kind of handout, it really doesn't connect to anywhere. It shows if it had an error when it was reading the folder, but other than that, it's more for just connectability than anything else. Okay, so I think we know where most things are, and I've kind of explained what each section's for, so I think we can move along reasonably quickly.
I have a question here.
Yep.
This sub-VI that is inserted into this current VI,
Yep.
it should show 3 points, right? 3 connectors.
Yes.
Okay, this one only has 1. Only this input 1.
So go to go to your connect. Sorry, that's fine. Right, go to. Whoa, did you drop?
Yeah, just
Okay.
didn't find the thing that you
Okay. So right click over there. Right click on it. Okay, and go to show connector. Okay, so you only got one thing connected.
Okay.
So click on your spool of wire. Yeah, there, and then click on this one. Okay, and then click on some other one on the left side. Just click on the one. Okay, and then click on input 2.
Okay, that connects these things.
So essentially, you're connecting a parent program to a daughter program.
Okay, so this creates these connections.
Exactly.
Okay.
So this, so it knows where the data is flowing through.
Okay. Good. And now do I have to update this?
You save it.
VI,
If you hit save it, it should automatically change to the new connector configuration.
Yeah, it does. Okay.
So one of the niceties of using the sub-VIs is you can make these small changes to sub-programs, just save them, and then they're automatically there in your parent program.
Mm-hmm.
So if you all of a sudden decide, you know what, I want 3 number inputs instead of 2 number inputs, you can just change it and you'll have an extra option in your parent program. Okay, so we're going to build this real quick. 1, so that you can see how to build it, and 2, because it's kind of a nice little sub-VI to have. Okay, like most things that deal with reading the reading file list names, we make our file path control, and then just for ease, so you'll notice that I use this strip path and build path a lot. It's generally easier to do that than it is to point to folders than pointing to paths. You have to modify paths if you want to select folders, so it's easier just doing a quick strip path instead. and just connect them up, just like in your diagram. So what we're doing is we're just pulling everything but the file name in here. So this essentially is the folder name. And then we need to see what's in this folder. So if we right click here, go to File Input Output, Advanced File Functions, and then List Folder. And just wire that guy over. Yes?
Street passes in programming.
It's in File Input Output. Yeah, so Programming, File Input Output. And then there's like two next to each other, Build Path and Script Path. You got it? Maybe? Got it? Cool. Okay. Then one of the things that it's not entirely necessary, it's kind of a nicety, and because this is a sub VI, you want to give use in the parent VI as generic as possible. You want to make this as usable as possible. So rather than we want to make this into a control. So if we, right click on it and create control.
Which backend came from?
So if you right click on the bottom of this one.
Where did it came from? Which sections
Oh, sorry. If you go to go to File Input Output, go to Advanced File Functions.
I put that one.
Yeah, and then go to List Folder. You get it? Not seeing it. And then, to make it generic, we want to give a control under the pattern. So create a constant, create a control where it says pattern. So that even if we choose not to put anything in there, at some point you might want to put it in there. So rather than having to edit it in the sub VI, you can let them edit it in the parent VI. So we can leave it blank, or we can put something in there. It's not a big issue. For now, we'll leave it blank. Okay, and in fact, right at this point, you can put the connectors on your front panel. So if you right-click on the icon, go to Show Connector, you can just stitch these together right now. So we can attach our path up there, and then put our pattern below it. Okay. So what we have here is a list of all of the file names that are within this folder, and we need to deal with them each individually. So we need to deal with it in a for loop. So right click on there, go to Structures, go to For Loop, and draw a nice, maybe not that big, draw a for loop, and then feed in this list of file names. So click on the file names, and then click on the edge of the for loop, and you should get this little double square bracket, and if you hover over it, says auto index tunnel, which means it's separating them out. Okay. Because this only gives you the file names, it doesn't tell you where these files are. If you want to actually deal with the file paths, you then have to rebuild this path, because this little VI doesn't carry over any information of where the folder is. And if you look at the little diagram, we stitch back on this path, mainly so that I don't have to add it back on the end. Technically, you can add it on. It's a constant essentially for this data set, so you can add it on wherever. I added on at the start so that I didn't have to carry it over right at the end. So what we need to do is rebuild these path names. If you actually look at the Labview VI, it does the same thing. It wants to deal with file names, so after it uses this function, it then has to put all of the file names back on there. So we go to File Input Output, and then go to Build Path, we use this path. So click on that path, and then the file name is whatever it says in that list. Okay.
Why did you take the path from here?
The path.
Not from this one?
Okay.
From this
Doesn't matter.
list folder?
Doesn't make any difference.
Okay.
So that was just a question of why I used this path instead of the path out. Makes no difference, it's the same. It's a duplicate. Okay, so once we've got that, we then have to figure out, well, if any of you guys come up with a different way of ordering this, then you should let me know, because this was just one idea that I had that kind of worked. So if anyone has any other ideas of how to order things like this, it'd be good to know. But the way I was doing it was figuring out how long this name is. You know, technically we can figure out how long this name is too, and it's the same deal, because this is just an arbitrary constant that's added to it. But for now, we'll just keep it all linear. So we have a path, and we need to know how long, you know, this path name is. So the first thing we need to do is convert it from a path to a string. Okay. So if you go to the string palette, which is in the programming, and then go to conversion, there's the little button, so path to string. And then we just want to tell how long that is. So if we go back into the string palette, the very first option is string length. So we want to know what the string length is. So for these ones that are really simple, if you're not noticing, if you grab the little thing that you're dropping on the page, and for these ones where there's like only one output option, if you just hover over it, it automatically connects it. You don't have to wire it up. So just to demonstrate that. So if I have this string length thing and I kind of hover over here, you know, it'll connect it for me. I don't have to get out of the connector tool. A lot of times it's more of a hassle than anything else because it connects up the wrong ones, but sometimes when there's one output, that's fine. Okay, so once we have the string length and the file name, we then want to kind of, you know, add this attribute to the file name so that we can sort using it. So if you want to add together two things of different types, we have to use a cluster because you can't make arrays of different types. So right click over here and go to cluster, and then we want to bundle things together. See if it puts it in the right one. Nope. Okay, and we're going to want to sort by the length of the file name first, so we put that in the first part of the bundle. And in the second part of the bundle, we want to put the bit of information that we want, which is this file name. So we'll stick that in there. Okay, and because we want it to do this for every file, we just want to run this to the outside. So just run it to the edge of your for loop. It should, you know, have one of these little index tunnely things again. Okay, so now we have an array of clusters which contain this information. No? No. You okay? Where you at?
My connection output is not pink.
This one?
Should I click on the boundary?
Yeah.
Oh.
So what you do?
Okay, so here. Yeah, so you're in a different, so you want to go to, right click and go to cluster, and then bundle,
Okay, so
and then if you wire it up, you should.
What's the difference between cluster and output cluster in this bundle output? Or
What?
if you look in context help on bundle cluster, it's like output cluster and cluster which comes to the second session. Like here,
Okay.
you have output cluster and cluster here. Is it some output? Or
No idea. What?
why did
it's not the same.
You probably it's because you can have together multiple types. Basically, it's saying one of those types can be like a cluster, so you can have a cluster and then add other elements to that cluster. So you've got a bucket of random information.
It's like
Yeah, so it's
additional
like
names to this
yeah.
cluster.
So rather than having different elements, which are single elements, you can also wire in clusters. So you can add other elements to clusters, and it's basically just an like kind of indexed pot to stick things. File name. You can put any old thing. It's
Basically the table structure in any programming language.
yeah.
I just see this. So the type of wire is changing when it's getting from the from this, what was it called?
This.
Cluster.
No, from the list folder thing into the for loop. It's kind of a thick pink wire,
Yeah, and then it goes thin.
and then it goes thin. What is happening there?
Yeah. So this is a for loop. Okay. And what we're doing
It
here.
takes it one by one. And
Exactly.
Then it's just,
So this little symbol here, or auto index tunnel, means whatever list you get, like now use one item at once, and every time I go around a loop, use the next line.
Yeah.
So it just goes down. You can switch it off. So if you right click and go to disable the indexing, one, it's not going to like it because it's an array. But if we ignored this for now and actually showed it, create an indicator. This essentially is an array of file names.
Yeah.
And on lots of occasions, you want to actually pull the whole array in, so you have to switch it off. It automatically, by default, thinks you want to index it. But we want to index it because we want to deal with each file name individually.
Okay, so now this whole thing comes as a bundle out from the
So right now we
from
have
the bundle part. It comes out like a cluster. It's funny because in the block diagram the wire looks different compared to the
this one and this one.
context help.
This
No,
one.
no. If you go to bundle, now
This one.
yeah.
Right.
When I look at the context help, then these wires that are shown there,
They're probably
kind
brown.
of brownish.
Yeah.
Here they are.
Right. Because because it's polymorphic, it changes it depending on what the inputs are.
Well, because
But
the
why
cluster
do you
is
name it?
undefined.
Because it's undefined, it can be all kinds of colors. The more variances, so the more different types of things you put in there, the more likely it is going to be brown.
Okay.
Because brown's like its generic output. It's like
Okay.
a bunch of things, so it's brown.
And since it's still such
in this
an
case, it's
indexed
yeah.
array,
In this case, it's kind of like, okay, you've got a number and a file name. Okay, I think this is kind of this color, right? It's more on kind of, one, it's hard to see, but also it's more on the thickness of the of the line that you want to look at, and kind of the whether it's stripy or spotty or.
Just checking the text.
Okay, so you have this. Next thing, you want to sort this list. So we want to do a quick sort thing. So if you right click and go to, I think it's in file input output. I don't remember, to be honest. Maybe it's not.
comparison points?
Maybe. I can't remember, to be honest with you. Doesn't look like it's there though. I might have to search for it. Tells you how much I remember since last night. I could have sworn I was here. Okay, well, it's a good time to use the search function. Sort. That's good.
It's an array.
No, we don't want that one. So, one thing that you'll see is I have all these other ones too. They kind of, it's not in here. So, one thing that there is with Labview is there's quite a big open source community. And for Labview, the open source community are known as OpenG. So, there are lots of people that write sub-VIs that they think are really useful and that more people might, get the benefit of. So then when you write them, you can submit them to the OpenG people, and then, if they like them, they'll include them in their bundles. So you can actually go, if you go to like OpenG, you'll find it in Google, and you can download their kind of modification pack, and they have all kinds of things that they think would be really good to have in Labview, like, slice this array at different parts and duplicate sections of array. They're filled with all kinds of additional functions. Oh, of course it's there. Okay, so that's the end of me being stupid. So right click and go to array, and then voila, it's into sort array. Obviously it's there. I don't know why I thought it'd be in the file palette. It's kind of crazy. Anyway, we sort the array, and now all we got is we got this sorted cluster. So now we need to then break this cluster back out. So we need a for loop again, because we need to deal with each file individually.
Don't we need to give any hints to how to sort this
Nope.
array?
Because we did that going in. So it will always sort, like if you cover over it or go to context help, it will always say it sorts from smallest to largest. Well, you have to go to detailed help. But it'll always sort from smallest to largest.
Okay, so it takes the first column basically,
Exactly.
which are the length of the
Right.
file names, and sorts it according to that.
Exactly,
And
first.
then the second category is the second column, which is
The full file
the
name, yeah.
actual number. then.
Exactly.
Okay, no.
So the important thing is that we're making it essentially sort it twice. It's sorting it first on the file name, and then the secondary kind of sort is on the file name. So one is the length, and the second one is the actual file name itself. And because, if we wired a 1D array of just the file names in, then it would do, just like it did before, where it kind of numbered them weird, wackily. But because we're giving it a cluster of values, it's got lots of other parameters. We could give it another one. We could put an extra index in there for, like give it a true-false value if, maybe not true-false, but give it an extra index for something else. I mean, it's...
Okay, so that's why it's important to have the length of the file name in the first column.
Exactly. If we put it in the second column, it will order them by file name first. So it'll put that weird ordering on first, and then it will reorder that list depending on how long each file name is.
But they're all the same within the same.
I don't know what it'll do there. So what it'll do is first it'll figure out where it is, but then there's only one for each one. So basically the indexing won't do anything.
No, but the second ordering cannot reverse the first one.
No, the first one.
So it goes, for instance, if you have that, it goes to something 1, 10, 11, 12. So it will have, for instance, 9
Right.
9 characters, 9, 10, 10, and so on until 19, and then when it goes on with 2, it should be 9 again. And it does not sort that because it
Right,
would
but that- but
contradict the
that's-
first.
Right, but that's what it does anyway, so essentially having the indexer there does nothing.
Okay, yeah, exactly.
Because yeah. But anyway,
This one is carefree anyway.
it's carefree. So anyway, we've got this, so then we just feed this into here, and like before, we allow the index. So now it pulls them out one by one, and it's now an ordered list, so we just need to pull out these things, so we unbundle this cluster. It's got a cluster, unbundle, wire this one in here. It should automatically detect which one is which. We want actually the list of these bottom ones, so the file names. So we just feed that to the outside of our path. Create an indicator on the end. So it's now creating an array of those file names. And if you want to, you can just clean up your diagram. Actually, it's big, so I can clean it up. Okay. Well, fine. Yep.
There's an error message between the end of the for loop and
Great indicator here. This is going to indicate this one. It is the sense itself.
okay, I have to create the indicator at the end of it.
Okay.
Already,
And now just so that we can pass an error through this thing, the only item in this whole sub-VI which will have it, I mean we can create our own error reporting system, but you guys will probably never do that. The easiest way is just on error n, right click and create a control, and then on the output of this one, right click and create an indicator. And what this will allow us to do is, one, be able to tag it in the diagram, but also it'll also tell us if there's been an error in the file list. If at any point you want to kind of add text to a section of this, you kind of just double click in the white space, and then you get the option to write things like list the folder. So you just do it by double clicking, and then if you want it to stay with a particular element, just put it as close to that element as possible. You can also attach these lists to wires. So if you double click and you want to, on very large VIs, where the wires run from many screens, sometimes it's good to put little markers in the wires, so as long as you put the text file or the text over the top, so if I put error and put this over the top, whenever I clean up the diagram, it will always keep that over the top of the wire. So if I'm working with a VI that's many screens long and I'm running wires all over the place, if you put these tags over the top of the wires, you know kind of where they're from. I mean, error is not very descriptive, but if you had like 10 different file input output things or image files or something, you can hover them over the wires, and then whenever you hit clean up, it'll always keep them together.
This arrow thing, it's called simple arrow or
Just
dialog in user interface?
just right click on the
The thing there you use?
yeah, no, on this guy, yeah. So
Exactly,
right click
yes.
there and then just click create control.
Okay.
It's the easiest way to run the error string.
Can you somehow see this naming when you're like?
No, but that's why you kind of put them. I mean, as you're kind of going along, and you have to look. You just tag it, and whenever you manipulate the diagram, it'll always maintain the tag over the wire, so you don't have to follow it all the way back to where you actually created the wire. Yeah, there's no way to tell what data's in the wire. Okay, so we have this, hopefully, ish. And just to kind of finish off, we're going to need to make sure because we're going to use this as a sub VI, we need to make sure that we actually have all the connectors and things in place. So if you go to your front panel, and then we kind of clean it up a little bit so it's not quite so crazy. So there's error in, there's error out there. Let's put that output there. Path here. And pattern here. Okay. So we should have something that looks a little bit like this, and just like before, to kind of connect it up, we just use this little spool of wire thing. So right now we have path in and pattern in, but we also need an error in. And it's generally kind of nice to put the errors in the bottom left hand corner, just for consistency. So error in there, and error out on the other side. And then we need the output from this, so we need the array 2. And we might want to call this something like list of file names, or file names. File list. And save it as something. I was going to say this is order session. And then this VI is essentially ready to roll. We'll implement this VI in next session's VI, but we should make sure it works first. So I'll just quickly test it on some data. I know what we're looking at. So start up underscore ch00.jpg. That'll be the quickest way. So I'm just going to look for a particular file because I know they're there. And hopefully it's not going to, hopefully it'll be right. So same folder set as previously, but now I stuck a whole bunch of other things at the end. And we've got some text files, some DLLs, so things that we don't want in the file list. But also at the start I've tagged a few files, and in fact let's just make another one. Oh, there is no files that look like that, Gavin. So if we just look at this list, then it's found 4 files. And it's ordered them in the order of 1, 2, 10, and 11, which is the order that it should want them in. And then if we look at the location that those files were in, then you'll see that there's an awful lot of other files. So we're actually doing the filter correctly, and we're doing the order correctly. So we got the file list 1, 2, 10, and 11. We got 4 files just like there is there. It ignored all of these guys because they don't have this file name C800. So it's working correctly. It's ordering on correctly. So it's a good subject. You know, just like with the other one, you can go make yourself a little pretty, make yourself a nice icon so that you can distinguish it. But other than that, it's looks good. Any questions?
Simply doesn't work.
Doesn't work?
No.
What doesn't work?
You should put in here.
Yeah.
Then shape this better.
Yep. So go back to your filter. Go back to your pattern. Okay. You've not got any character before copy, so it's looking for files which only have the word copy.
Ah, okay.
So you have to put a wildcard, put a star. Yep. Exactly.
Okay.
So now if you try and run it,
Yeah.
it doesn't look for the pattern at any point. It expects that pattern to exist. So if you want to have, you know, if you want to have something in there, we have to put a wildcard there first and say, look, just expect this end of the file name. Similarly, if I just wanted JPEGs and didn't want the text files and all the rest of it, all I would do is just say star.jpg. And then it would ignore the text files and DLLs that I stuck in there. But this is a good use that if you're going to take the data from the confocals and only want to look at one of the channels, you'd run this sub-vi first when you point into the folder. Point to the folder, tell this, and then it will only work with, you know, channel 0. Okay? Any other questions? Hopefully it's working.
What if there are subfolders? It also goes into those, right?
If you ask it to.
Wait a second.
Is it doing it by default?
I'm going to pictures and then I take every PNG and then it. Oh no, that's just some kind of mistake, I guess. And then it puts another. I mean, it takes. There's already the file, the complete file path, and then it adds, as if there were another subfolder. It adds another.
Where is this folder?
That's just mine. Oh, no.
Yeah, you just.
No, this has. I think.
Just click on the thing and let you pick the character.
I mean, I just want to take this, and I just want to like numbers of pictures here that end on PNG, for instance. So I just like select any picture now, I guess.
Yeah, should be able to select it.
Like this one. Or do I have to remove this part?
No, don't touch it. Just run it like that. No, don't touch anything. Just run the. You don't delete anything.
And this is element 1, 2, 3 here, I guess.
Yeah.
So that's on the side.
It's,
Is this a filter?
It adds this. Yeah, it adds this string here to every file name. I don't know why.
you should.
To remove these two. Now it's only the folder.
Oh, yeah, that's because you applied it to the wrong part.
I have to do the strip one.
Yeah.
Oh, okay.
I think
Really good.